Good morning, dear Lucidus Training Day participants. I warmly welcome you in our annual Training Day by Lucidus. This year we are meeting in a new reality. It's happening remotely. And as Friedrich Nietzsche said, what doesn't kill me makes me stronger. And with these inspiring words, we would like to start our training day. So to warm you a little bit up and remind the rules which we should follow in these remote sessions, I am saying that please note that your questions can be asked directly only in question and answer session. So to ask a question, please raise a hand. Or you can write your question in the chat box, and we will try to answer the questions as soon as possible. So when we have reminded you the rules, we would like to start with the first warm-up polling. So please, can you state the polling? Which time you are attending the training day? First, second, third, or maybe 256? And when we have talked main rules and started the poll, I would like to remind you our today's plan. So we will start with Mrs. Tiiu Tamm at 9:10. At 10:10, we will see the presentation from Nico Group, carried out by Mr. Holmer, Mr. Gelhardt, and Mrs. Karen. At 11:40 will be a small lunch break, and at 12:10 there will be a Lucidus case study at Anatomy Museum in Riga. After the case study, there will be a presentation from Nedal Aluminium, and after Nedal Aluminium, wrapped up by FLIR Systems from Germany. To follow our program, you can see it also in your emails. And now, I think that we can try to connect to our first speaker from Estonia, Mrs. Tiiu Tamm. She knows more about light than we can imagine. And there are even rumors that Mrs. Tiiu Tamm knows from where the light comes from. So Tiiu, do we have a connection already?
Yes, I have connection. Good
Perfectly.
morning.
Good morning, Tiiu. So are you ready to carry out the presentation?
Of course, I am always ready.
Perfect, as a pioneer.
Okay,
So
I take over the
yes,
screen.
yes, of course you can take
Okay.
over the screen. So good luck to you.
Thank you.
You can... Yes, you can start.
Yes, I start immediately. Hello, I am Tiiu Tamm from Estonia, and I am electric engineer and dedicated to everything about lighting. The first, I have to apologize my poor English, but I hope you understand my presentation. We need light not only to see. Light is one of the main drivers of circadian system. It affects to our brain. I try to show here a little bit. I hope you see it. And through brain affects our hormone levels and the sleep-wake cycle. You can see different hormones and where it impact here on this screen. This is a sign how productive we are, and everybody wants to be productive. A little bit. Okay. There is so many different surveys in this world. How the light impacts to our health and productivity. Here you can see only one survey from UK. 77% of office workers believe that lighting in the workplace affects their productivity. 33% say that access to natural light is important, and 32% say that they would be happy to work on the artificial light that is designed to aid productivity. The survey results suggest that whatever lighting's direct biological effects are, humans at least psychologically react to illumination. You may be surprised why I talk today about topics from medicine science, but this is important topic to be healthy and productive. And we all want to be healthy and productive. I can say that so many customers call me to consult them. Why? If there is all light done like in standard, the workers are tired and not productive, especially in the autumn and winter. Of course, the light is not the only reason, but very important reason. Too few light in the daytime is bad, but too much light in the evening is bad too. Last year, we talked about a correct calculation of maintenance factor. Using correct maintenance factor in the LED lighting calculations, we get too much light always. It means that LED lighting need to dim. Because of health effects of over-illumination or poor spectral light distribution cause worker fatigue, increased headaches, medical stress, decrease in sexual function, increase anxiety, symptoms of different diseases increase, circadian rhythm disruption due to wrong timing of light. For example, too much light in the evening or at night makes us awake, and it is hard to go to sleep. Too few light all day means that melatonin level is very high in your bloodstream and we are tired and do not want to work. In the long period, it means depression, etc. But nobody from us don't want to be in depression. In the world, there are everywhere companies who study office conditions and how these conditions impact to the productivity. Here you can see one of these companies, short report from Germany. Here you can see where it is from. As you can see on this graph, the workers understand that the lighting conditions are the most important, but satisfaction is under 60%. In modern offices, we hear often that there is done everything to the workers. There are plants, fitness possibilities. You can even take your pet with you, etc. But nobody talks about lighting and climate. Harvard health scientists found that if indoor lighting environment and ventilation are in the good condition, the cognitive functions work better. Together, it has positive impact on our sleep and wellness too. Good visual communication and recognition of objects require cylindrical illuminance calculations. I don't know how in Latvia and in Lithuania, but unfortunately, Estonian electric engineers do not calculate this in their projects. They concentrate only to the horizontal illuminance on the task area. This is a small problem all time. I can't hide the screen sharing, but here you can see if here is all normal illuminance and the light comes here and is ahead of our eyes, that's all normal. But if happens that the table is illuminated normal, but nothing comes to our eyes, then we are not awake. Melatonin is not suppressed. However, if the task area is it does not matter, do we use in this room turnable white light to get human-centric light or not? We talk so much, so many about human-centric lighting, about turnable white light in offices. But the most important thing is how the light is come to our eyes. Of course, we have to avoid glare. Cylindrical illuminance, you can see how it calculated. It's here. By standard, the height of horizontal plane shall be above the floor. For seated people, 1.2 meters. For standing people, 1.6 meters. Special attention is given to those spaces where visual recognition and communication has higher importance. In the offices, it has to be at least 150 lux. In the next standard version, we hope it will come out soon in this year. There are for every task area different I forgot this cylindrical illuminance demands. Now I show one picture. This picture is from one school first form in Estonia some years ago. Very low ceiling and very strong light from parabolic optic system gave cylindrical illuminance only 27 to 42 lux. Eyes of the children were in pain in the evenings and the municipality gave it to court of justice and won. But this is not only one example. I can give so many different examples where cylindrical illuminance is problem. Here you can see the spectral sensitivity of the 5 known human photoreceptors. Thomas Young described in 19th century that in our eyes there are 3 types of cones: red, green sensitivity, and blue sensitivity. Together, RGB. We all know RGB light. And the scientists found later rods. Here you can see here. And in the beginning of this century, intrinsically photosensitive retinal ganglion cells. This is this graph. These cells contain melanopsin. Melatonin is sleeping hormone. Melanopsin suppresses melatonin. Today we know that if there is big part of light in this area, it means in this area, in this graph, ahead your eyes, it means melatonin suppression. And in the morning and afternoon, this light helps us to be in daytime circadian rhythm. In the evening, we need less blue-green part of light to get us ready to go and have good sleep. Of course, if you watch this graph, you can see that melatonin starts to grow after 6 somewhere. But we don't be sleepy soon. It takes time, 2-3 hours to go sleepy. That's normal. Traditional lux meters measure visual stimulus response. Here is visible light. I forgot to show it. Melanopic lighting is lighting that is turned to both. And here you can see visual. Melanopic, it means non-visual stimulus. It is turned to our visual and non-visual responses to light. It means our brain reacts to the light and wake us or prepare to go to sleep. Oops, sorry. The biological effects of light on humans is possible to measure. Who met me last year in Riga maybe remember I had this kind spectrometer. It is from Sensatec Lighting Passport. This is from gigahertz optic spectrometer, and this is GL Optics Spectis. All these spectrometers can measure how the light gives to be us awake or prepare to go to sleep. There are different metrics developed separately, but they all work. Equivalent melanopic lux was developed by WELL standard. I think you all know something about green building standards. They are very different. Mostly they contain energy saving and environment materials. WELL standard is more than green building standard. It means everything is important. Not only energy saving and environment materials, but human itself too. It means light, food, communication, nations, etc., etc. I suggest to watch a little bit yourself what demands are in WELL standard. I can say in Estonia still not no one project by WELL standard. Lithuania got some years ago 2 first standard certification by WELL standard, and in Latvia, I don't know correctly, there are 1 or 2 projects. In Estonia, nothing. Equivalent melanopic lux is alternate metric weighted to the intrinsically photosensitive retinal ganglion cells and melanopic stimulus. It takes account IPRGC response by light spectrum quality and quantity and age of human, but does not take account of rods and cones sensitivity. It is measured, here you can see, on the vertical plane at the eye level of the occupant. The amount of light on the vertical plane depends on the luminar light distribution and reflection from the walls and ceilings. And of course, light from the windows if you have their windows. In the dark room where dark walls, there is nothing to reflect into the eyes and you get worse result. Unfortunately, Estonian architects like dark, even black walls and black ceilings. And the another alternate metric system is circadian stimulus. It quantifies effectiveness of light sources for activating the circadian system. circadian stimulus developed by Lighting Research Center in USA. It takes account the response by all types of photoreceptors, rods, cones, and IPRGCs, but not takes response of age. Circadian stimulus is equivalent to percent melatonin suppression after 1 hour exposure to the light source. Delivering circadian stimulus than 0.3 or more during the day, especially in the morning and low circadian stimulus under 0.1 in the evening, we have normal awake sleep cycle and are ready to be productive. Unfortunately, I have met so many customers where I see that circadian stimulus is under 0.1 or under 0.2. It's too few light to our eyes. Same scheme helps to cure different disease patients, even like Alzheimer, cancer, etc. Of course, at night, they need to sleep in the completely dark room. Results show that sleep efficiency and total sleep time increase, but agitation and depression decrease in this case. Melanopic equivalent daylight illuminance, MEDI, is only metric what is in the standards. The others, what I talked earlier, they are not in standard. But MEDI, it helps to understand how much a given spectral distribution of light can effectively take part in melatonin suppression during the day and affect our rhythm of work and rest. This is the first international document that sets out the calculation method of human-centric lighting. A high melanopic equivalent daylight illuminance during the day is usually supportive for alertness, the circadian rhythm, and a good night's sleep. Plus, a low melanopic equivalent daylight illuminance in the evening and at night supports quick fall into sleep and have a good sleep. Here is melanopic response. Melanopic response graph is this one. And spectral power distributions for equal melanopic equivalent daylight illuminance 250 lux from different LED sources, what was used in study in Mount Sinai Hospital. This is very interesting study because everybody can measure with traditional luxmeter how good light you have. You don't need special spectrometers for this. In the table, we can see the results if you want this use. And this table is only for LED light sources. Maybe you know sunlight, it was the first full spectral LED light source what was on our market, and this was like sunlight, and that's why sunlight is in this table too. And we need to get 250 luxes to be healthy and productive. Maybe you have heard already about double dynamic lighting. It is a very new topic. Tridonic Fagerhult, Iguzzini, Sumtobel sponsored Aalborg University scientists research, is it possible to define dynamic light settings responding to the dynamic of daylight in combination of direct and diffuse lighting? They used turnable white luminaires in the ceiling with microprismatic optic and 3000 Kelvin spotlights in on the every working place, direction from the window. Same like light has changing outside, they changed light inside. 3000 Kelvin spots are like sun in the blue sky. They worked out 7 different scenarios for office work. In the first phase, they studied, does it have positive impact to work, but not how? The answer was yes. However, the last phase in this study was only 4 months long and there was only 4 participants. The workers described their experiences like they didn't notice the light, but it was comforting in the room. It feels like daylight in the room as it was so natural. One person said, in longer time it is possible that the light will be motivative to do the work. Team analyzed perceived visual comfort between dynamic and static lighting periods within the same season, especially showed study good result in October and November comparing to static lighting. However, the team didn't study the results of melanopic lux, circadian stimulus and melanopic equivalent daylight illuminance, but they made all measurements. And I got this data after question. Shortly, lighting CRI was over 90. Lighting correlated color temperature was in front of eyes between these numbers, how you can see here. It depends on the working table position in the room. And vertical illumination ahead of the eyes was very good. And if we compare this data with Octavio's table here, we can compare here precisely even here. We can see that this study is very successful and interesting and has good idea how is possible to solute circadian effective light. This is not window, this is luminaire, like window from Italian company Coelux. Luminaire is in the wall. Here you can see this luminaire. But this is only mirror. And it gives effect like bigger window. And all, if you watch this picture, we think like DDL, double dynamic lighting. Thank you for listening. I don't know, do you ask now the questions?
No,
or
the question part will be after all your presentations, so you can start to switch on the second presentation. But I have read that Leonardo da Vinci said that the best day for painting is a gray day when there is not too much light, so it's not overlighted. I think that you agree with this as well.
I don't know, I don't paint.
But still, you know more about light than I think everybody in our audience. And breaking news, currently our audience is more than 100 people. So your audience is listening very carefully.
Okay.
So, and
it's a little bit scary.
While you prepare, can we run the second poll? Is it already running? Yes, so technical guys are saying?
Yes, it is already running.
Okay, perfect. So, are you ready to continue? Oh, we see on screens already some data. So your presentation is ready? We can continue?
Yes, my presentation is ready.
Okay, Tiiu, so please continue with the second part.
The next topic is challenges in street lighting. Here I talk about different topics what come up in the different projects. This is not one part. Here is some different parts. Here are standards and EU criteria for road lighting. I do not read them to you, but I want to show the last one, what is here. This is very good document. Who is interested in, you can find it from internet too. There are both from 2018 year and 2019 year in the Google. Use 2019 version if you want to use it. The first part of road lighting standard helps to assign to different streets lighting classes depend on traffic. In the standard, you can find good tables, and calculator needs only to answer these questions to get lighting class. Of course, it is possible that you calculate different lighting classes for peak time and for night, but usually Estonian customers do not expect so precise calculations as they want to see by their own eyes how much they can dim lights at night. In the last column, here are waiting numbers, and after answering, you got these numbers, what you need to divide from 6. Of course, the second part of the standard is important as there are the values for lighting classes, but I want to explain the fifth part of the standard. To decide between different solutions, it is important to watch power density indicator and annual energy consumption indicator, because of these numbers show how good solution is and how much the road lighting electricity will be cost. Power density indicator shows how precisely the needed area is illuminated. If you illuminate not needed area too much, the power density indicator is bigger. Annual energy consumption indicator shows how much money the customer expend for energy to light this needed area, only for this needed area. If you light too much not needed area, the customer must pay for lighting energy much more. Here you can see one calculation example for Dialux Evo. Power density values are almost same, but usually the difference is very small, but it is. But annual energy consumption indicator is very different. Here you can see. Of course, we can watch power per kilometer to say same in this project, but sometimes we have in the new installation situation with different luminaires, with different distances between poles. And then are power density value and annual energy consumption indicator the best solution to find what is the best solution. Unfortunately, most of the customers look only procurement expenses, but correct is to look all expenses. It means procurement plus energy expenses in 20 years or 25 years. However, we do not know energy price, but we know calculated power density and annual energy consumption indicator. Then we don't need to know electricity price. Lower value of DE and DP means the better energy performance. They depend on many factors: lighting class, road profile arrangement, width of carriageway and sidewalks, type of the light source, quality of optics, etc. Common mistakes to find energy efficient solutions. Efficiency versus efficacy in lumen watt. Everybody talks about efficiency, but compare efficacy numbers. It is wrong. Lumen per watt is luminous efficacy unit. If we compare two different luminaires, it is possible that luminaire with less efficacy has better power density and annual energy consumption. Efficiency doesn't matter in this case, because efficiency shows how much light we get out of this luminaire. But what the light illuminate, how much needed part or not needed part, it doesn't show. Power density indicator with annual energy consumption indicator helps us to find the best solution for years. It means we need to compare solutions with DE and DP, not efficacy. Calculations with console in one project where the customer asked my expert opinion in Estonia. It was this project was built with European money. And you can see the project like the electric engineer calculated it. As the road is 6 meters width, but luminaires are, the post of luminaires are far of 6 meters from this roadway. The electric engineer needed to inclinate the console 50 degrees. What does it mean? The first, we have light pollution and light trespass. You can see it here. Some of light goes up. We didn't talk, maybe here are some houses. It means light trespass to their windows all nights. Maybe here is forest. There are nightlife and with daylight life, all flora and fauna, they need to sleep. They don't need this light. Okay, I said that to the project engineer, you can't calculate this way. You calculated it wrongly. You have boom angle 50 degrees and boom console length 1.5 meters. You don't get this result afterwards. And the LED lighting need to be parallel to the ground. Electric engineer looked at me and said, no problem, we put the luminaires parallel to the ground. Sorry, here are so many mistakes. Okay, in his calculation, we can see here the threshold increment. It is clear, 17, but need to be less than 15. But all these calculations are wrong. But let's see before the newly calculated slide, I show what is power density indicator. You can see it is quite big, and annual energy consumption indicator is really big because so many light goes here, not here. In specification, okay, I show back. You can see light spot height 7 meters, but in specification was woody pole 9 meters, 7 meters on the ground. It I took from the specification. This picture I took from Tiiu's side view, and you can see he calculated 7 meters, but the post is itself 7 meters. It means this is wrong high. Okay, let's calculate in this situation. We know this is 7 meters, this is 1.5 meter, and here is 15 degrees. We need to know this high, and we need to know console projection to the ground. If we use a little bit sinus and cosinus, we can get all this data. And after little calculation, we see that height of luminaire is, instead of 7 meters, it is 8 meters. And boom length is, instead of 1.5 meters, 1.14 meters. It means overhang is different than he calculated. And here you can see this top is electric engineer's project. Only threshold increment is not okay, but here is my calculations if I corrected the data. Only what is okay is threshold increment, but all other data are not. Did you understand how our project engineers make all time the mistakes if they use boom inclination? Okay, let's see. Power density indicator is in my project even worse, because we light only this area what doesn't need light. But annual energy consumption, it's same. This is normal because we use same luminaires and distances of the poles are same. I hope these slides put you think about this topic much more if you have to make calculations about with angled booms. Let's talk about light color. 3000 Kelvin or 4000 Kelvin. Maybe 2000 Kelvin, 700 Kelvin, or even less. Some people do not use curtains on their windows. Wrong luminaire or wrong position of luminaire cause light pollution. In 2016, American Medical Association suggested to use in these areas where the people live warmer light sources due to less glare, melatonin suppression, and circadian disruption. Some years disputed about this because producers like to show very good efficacy to their luminaires, and golden light color gives mostly this possibility. But who is more important, residents or producer? Producer or we, us? Today we can find many examples where the street lighting is not only 2700 Kelvin or less, but even turnable white to use in different time, different light color. On these graphs is melanopic curve. You can see it here and here. And you can understand why in sodium lamps solutions time we didn't meet so many problems with circadian disruption than with LED lighting. It means we have to very correctly make our projects. Some pictures about light trespass in Tallinn. This picture is taken from apartment inside of one apartment. Here are luminaires 2 meters from window and never gives to have possibility to the dark room at night. Here you can understand yourself too. 2 pictures from 2 small towns in Estonia. These are from traffic cameras pictures, and you can see these people who live here or here or here or here, they have all time lighting trespass in their windows. Pedestrian crossing is conflict area in the standard. But with these pictures, I want to show that it is not so simple to calculate only conflict area. In certain conditions, it is easy not to see the pedestrian. It depends on climate conditions, what color clothes the pedestrian wear. Does it have some reflective sign? Is there other cars driving towards you and how their headlights work? Are these normally regulated, etc., etc.? Let's see one video what I made 3 years ago. I put my husband to walk on different pedestrian crossings. Here you can see there is a crossing. There are luminaires for crossing. Okay, I hope that it put you a little bit to think about crossings lighting. To get positive contrast, Estonian, we have in Estonia special standard what we took over from Germans. and how to calculate luminaires for pedestrian crossings. To get positive contrast on the pedestrian crossings, it is important that there is light before pedestrian. Here you can see. Towards to the driver. Only then can driver always notice someone on the crossing. Part of drivers are old, sick, or just inattentive. Good location for luminaire post is like here on licht pages. You can see approximately half to one post high before crossing. Then the pedestrian is visible to the driver. Yes, you can say that in my video the crossing luminaires were directly near the crossing, and you saw how good or bad the driver might see the pedestrian. Videos are done without driving. Cars drive quickly and conditions are different, may say even worse. About luminaires for crossing, we know that road administration wants to use same post for other info too, like traffic signs and lights, and almost never let to put the post so far from crossing. That's why we calculate crossing light separately. In our standard, it is important that average vertical illuminance in the center line is minimum 30 lux on the 1 meter high. 1 meter on sidewalk, here you can see it is part of the crossing, because a driver need to know is there anybody waiting to go over the road or not. At night, we need less light on the roads. There are different possibilities to control night lights. Teachers asked me how to know what lighting glass to use at night. If municipality does not know, samely we don't know. I didn't notice that in Estonia anybody makes calculations for nighttime with different lighting glass. However, this possibility is in the standard. Usually customer decides yourself how few light to give at night. If the customer can change your self light level, then usually they decide this by their own eyes. What is the best solution? And trust them, of course. If they order luminaires with astrodim or dynadimmer, then they must know how much they want to dim at night. Don't forget that in our climate the LED lighting behavior a little bit differently compared to calculations. There is much colder in our climate, not plus 25 degrees, even in the summer. But we need to do what we need to do. We need to ask right questions. The first question, do we need lighting control? Where is the limit of power or luminous flux not to dim lights? Is it 25 watts, 31 watts? As LED lighting all time goes better and better, it means maybe the limit is 25 watts. We don't know today. The second question, how competent is customer to use different lighting control systems? Maybe there is enough to use only like dynadimmer. It is like astrodim, chronodim, etc. For more complicated systems is no easy solution. Use D4I luminaires with ready-to-saga nodes. This is solution what can build separately in different times. If the customer has no money for all or do not know what he wants. In these luminaires is ready DALI net here in the luminaire itself. And you can add sensor or a wireless control node, whatever when. I asked from Estonian outdoor lighting control guys, what does it mean in money? And they answered that one wireless Saga node is cheaper than and they like to use it. If I asked same question from producers, the answer was, it depends on. But mostly the final price of luminaire itself may be a little bit more expensive, but not always. Saga and D4E certification gives confidence for interoperability. You can use different nodes or different producers. As my time is soon finished by ending, I do not read these arguments, but I show a small Saga video, what is done 3 years ago. I took over the, sorry, it stopped. Here you saw a small presentation. Oops. Thank you for listening. Now we have 5 minutes to answer.
Yes, we have now questions. A small time for questions. So, can you please stop? Okay, thank you. So, as I saw from the presentation, so the devil really hides in details. You can make a small mistake in calculations and the result will be really poor.
Yes, that's true.
So now it's really important thing for all the designers or planners. But now we can go to questions part. I see that from the polls, there are some attendees, I would say 6 of them, who believe that HL or human-centric light really stands for Batman. So we are happy that someone believes in real Batman. But now, do we have any questions from the audience?
About human-centric lighting, I can say we have in Estonia so many projects already, and
Yes.
buildings where are done human-centric lighting. But
Okay.
what I wanted to say, it doesn't matter. Do you have human-centric lighting? It's very important how much is light coming here.
Is it correct light?
You can put, yes, is this correct light?
Yes.
This is what I wanted to say with my first lecture.
Okay, this is one of the most important things, to have the correct
Yes.
light, not only centered
Yes.
on somewhere. That's correct.
I think
So
most of you have in your company lux meters. Let's try how much light is here. Put the lux
face.
meter, no, not here, but this kind.
Yeah.
How much
Facing to-
luxes you get, and
Okay.
watch into Octavio's table.
Yes, and also the
And you
correct
have-
spectrums, because there is a visible spectrum.
You don't need a spectrometer if you have a LED lighting.
Oh, of course.
You can see. This is amazing. How few.
There is a question, and the question is, just a sec, I will read it out. The question about Jaga. How to choose between Nema or Jaga? Do you have some information about that? What are the differences between Nema and Jaga?
I don't know everything because I never used Nema, but in Nema there was Nema socket need added power supply. But there are new Saga book what makes Nema socket usable too now. I can't answer to this question. You need to write in Saga book. You find all data sagastandard.org.
But the best advantage of Jaga is using low voltages, not having the...
In Saga, they no, not only that low voltages, if you have D4i driver in the luminaire, and the luminaire, all the Dalinet is done, and you have Saga connection done in this luminaire. What is the best side is, if I today don't have money to have lighting control, then I put only luminaires there. And if I have tomorrow the money for lighting
then
control,
there is
to
space
make
for
this,
improvements to get your
yes,
luminaires more efficient. That's very nice.
And you can, whatever time, you can add these Saga nodes or sensors to this luminaire without open the luminaire.
But there is one more question from the audience, and this is about illumination in parks or squares, because we were talking about streets. There is a street light levels. But what about parks, and what to do there? What are your recommendations? Do we use the same color temperature or dimming levels or light classes? Can you explain about that as well?
We have not light classes for squares and for parks. We even do not have for parks standards.
Okay.
It depends on what we want to do there. This is not easy question. It needs lection.
Okay, but there are no regulations on that. It really depends.
There is no regulations, but we need dark skies, dark parks at night. It means we need to illuminate only at night only these roads where we walk to be. It means we don't want to rob it or beat it. I hope that you understood me. My English is poor, as I said.
No, it's fine. We really understand your
I
idea.
I don't find right words so quickly.
Okay. So thank you for this information. So there is one more question I see. So the light aesthetic side more important than the light side in town squares. So that we more look on how luminaires look, not so much in illumination part. What do you think about this question? Is it reasonable to do that?
This is a two-side question because the most important it is that we can safely move on these roads or parks. In the other side, if this is square, it is public square, of course we want that it looks very nice too. And this is possible to find this kind of solution that this is safe place and looks nice.
Okay, thank you very much for your answers. Thank you for your presentations, Tiiu. And as the time has come, we now have a small technical break. All the other questions we will answer in emails and send to you the answers, or we will try to answer in chat. But now, a small technical break, and we will meet in few minutes for the next presentation from Nico Group.